Hello everybody and welcome to this next Java video tutorial. Today we are going to be talking about something called methods. And this is a little new from what we've talked about in the past, and this is very important in Java, so this is a very important thing to understand and be able to internalize and use comfortably, so pay close attention. So the natural question to ask is, what is a method? And a method is something we use to break a problem into pieces. And so if you have a large task ahead of you, maybe you have to plan a particular event or do something that's relatively complicated, it might be overwhelming if you tried to do it all at once. And so instead, you'd sort of subcategorize things into little pieces and focus on those pieces individually. You might assign different tasks to different people, give people different responsibilities, and as soon as you say, hey, you take care of your responsibility, as long as you trust them and know that they're going to do what they're supposed to do, you can stop worrying about it. And so all you really need to do is orchestrate what everyone else is doing, and that's your job. And then it's up to people on an individual level to make sure that the task at hand is facilitated properly. And so that's really the idea of a method, and it's something that we can basically use to make a little subroutine in our code that will run when we call upon it and take care of things without really us having to worry about things anymore. And it makes code less cluttered, and it makes it so that we can focus on important things and not have to worry about all the little details all the time, because that would make things very overwhelming and impossible to deal with. So, if you are very comfortable with the idea of a function in math, you might want to skip ahead here a little bit, but we might have some young coders on our hands, and if that's the case, that's wonderful. So here I'll discuss something essentially about what a function is and what that means. So the idea of a function is that we put something in and we get an output. And so there are a lot of examples of this. And what we find is that the input is going to influence what happens to the output, or in other words, the output is dependent on the input. So here's an example. How about calculating a tip? If I ask you, hey, give me the tip of some meal at a particular restaurant, I say, we need to tip the waiter, so we need to come up with how much we're going to tip them. And you say, okay, I can give you the tip, but I need to know something else. And that something else is how much the meal costs to begin with. And so the input is the meal cost, and the output is the tip in dollars. And so in this sense, the tip is going to be dependent on the meal. And what we can do in Java is we can set things up that have a name. And so in Java, you can do something, and I'll implement this very shortly so you can see this, or something of the sort. Basically, what you can do is say something like Java get tip when the meal is $100. And when you do that, it will go in and you can define get tip to be whatever you want. So in particular, when you get the tip of something, you might be taking your value of the input and multiplying it by 0.15 if you want to give a 15% tip. And that is what your output is going to be. And so in this sense, the tip is a function of how much the meal costs. And when you say, hey, give me the tip, you need to tell me also how much the meal costs so that I can effectively give you the tip. And so we are going to look at that in Eclipse in just a moment. So here we are back in Eclipse, where we're going to look at the implementation of methods and exactly how that works. So Here we've still got our relatively boring class Hello World, which will change name soon in order to better reflect some Java concepts, but don't worry about that. And we are inside our main right here, and this is where our code starts running. And I'll even make that a comment. Code starts running here. So we know that when we type some stuff down here, the code will run and will do things for us. So let's say we wanted to add two numbers together, and this will seem a little silly at first because we've done this before, but just for argument's sake and for example's sake, bear with me. So I'm going to declare an int x equal to 4, an int y equal to 6, and then I'm going to say int z equals x plus y. And as we well know by now, if I print out z, I will get 10 down here in my console, because we have x is 4, y is 6, z is 4 plus 6, which is 10, and then we print out z. Now let's say I wanted to do something a little different, and instead of adding two numbers, I wanted to square a number. So let's say x equals 4 and z equals x times x. Int z, because we need to declare it. Then, when I print it out, we're going to get 16, because 4 times 4 is 16. But what if I got tired of typing x times x everywhere, or 4 times 4, or 5 times 5, and things changed, and I wanted a little better way to do that? And again, this isn't the best example in the world, but this will serve as an entry point so we can move on to better examples and see how we can really unleash the power of methods. So what I'm going to do here is, before, we've always typed inside here. But now what I'm going to do is move down so that I'm typing in line with this public static void main. And I'm going to start building a method here. And the method input will be some integer, and the method output will be the square of that integer. So I want to make a little function that says, hey, you number, I want your square, so I'm going to give you the number, and now that you have the number, you can figure out the square, and you can hand the square back to me so I can use it somewhere else. And so here's how we set that up. First, we're going to start with the output type. So we begin with the output type, and that is int, because we're going to be getting an int back. If you square an integer, you're going to get an integer back, so our type is an int. Except, what I forgot, silly me, was that we have to put this keyword static here, and the static basically means that this method is not associated with any particular object, and we'll talk a lot more about that later. But, for example, you could have a method like telling a person to walk, or telling a teacher to teach a student, or telling a car to run. And all of those methods are very specific to those objects that they represent. But here, we're just squaring an integer that's not really associated with anything, and so if we pretended that it was a particular object squaring an integer, we'd kind of be deceiving ourselves. And so what we really want to do is put this keyword static here, that we've also seen up here before, to show that this function, this method, is not particularly associated with any object that we can use. And this will make a lot more sense later, so still just bear with me. Then we need to give it a name. And so this is going to be the name that we call our function with. And in this case, I'm going to call it getSquare. But you can call it whatever the heck you want, because as long as you're consistent, the computer will be able to find it and know what you're talking about. So then we're going to put some parentheses and put what we need as our argument. So, and there could be more than one argument, but for now we're just going to have one argument, and that argument is going to be an integer. And so our argument can be int number. Now, this name number is a temporary name. And so it really doesn't matter what you call it, because that's just going to be a way to refer to whatever number we put in here. And so I could call this cats, dogs, fish, people, chair, and as long as I'm consistent within my method, it will be able to handle things appropriately. But it's good to give them kind of intuitive names so that you don't forget what you're doing. Okay, now I'm going to line down, open curly brace, enter, and Eclipse kindly completes the other curly brace for me and tabs me over. So right now you should notice this red underline, and your instinct should be to start freaking out, but don't, because this is an error saying that we need to add a return statement to our method. And this actually makes sense, and I'll explain what a return statement is. The return statement, return, is a magic purple word in Java, and it means that whatever I put here, whatever goes inside there, or whatever goes on the other side of return, is going to be handed back up to the top. And you'll see this in a sec. But basically what's happening right now is we're saying, okay, we've got a method called getSquare. I'm going to give you an integer, and you're supposed to give me an integer back. But right now we haven't told the method what integer it's supposed to give back. Just because I say getSquare doesn't mean that it knows what to do. And so I need to tell it what to do. And at the end of telling it what to do, I need to most importantly tell it to return some integer back to the top as the answer to whatever the square is. And so right now it's just red and unhappy because I'm telling it that it's supposed to get an int back, and I'm not giving it anything. But as soon as we complete the method, that red underlined unhappiness will go away. Alright, so I'm going to create another little temporary thing called my answer, which is an int. And my answer is going to be the number times the number. So my answer is going to be the number squared. And notice that this number, this variable name, and even when I highlight it, it shows me, that variable name has to match whatever temporary name I chose here. But if you change those all to cats, it would still work. And then what I want to do is return the answer. And now it's all happy because what I'm doing is I'm handing the answer back up to the top. Imagine sending someone a request for the square of a number saying, you know, hey man, can you please give me the square of this number? And he says, sure, what's the number? So you put the number in, and he does his magic in here, and he calculates the square of the number by multiplying it by itself. But then he has to give you an answer, right? And so he has to return the answer to you and maybe hand you a sheet of paper that has the answer on it so that you can use it. But until he does that, you still don't know what the square is. And so that's what's really going on here. And so this method is ready to use, and the way I call upon it is just by saying getSquare, and then the argument, whatever number I want to get the square of, goes inside here. And so I can even getSquare of 4. And you'll notice that it got italicized, and that's because it's a static method. There'll be some non-static methods in the future as well, but don't worry about that. And so I'm handing it 4. GetSquare says, okay, we've got this number 4, that's our number. Let's take the number, let's take the 4, set answer equal to 4 times 4, which means answer is 16, and then hand the answer back to us. And so this hands back the integer, but if I just did this, this wouldn't really do anything, because this would be like just a number floating there, because we don't have anything to store it with. So if I say getSquare of 4, that's going to take 4, and it's going to hand 16 back, but doing this would be the equivalent of doing this, or something like that. It'd be saying like, it'd basically just be a 16 floating around, because it's not actually doing anything, and so we need to capture that value in a variable and print that out, and we'll see that just as before, we get 16. And just to convince you that that wasn't the same as the last one, we can put a 7 in here, we'll get 49. We can put 13 in there, get 169. And so what we've created is this little function where if we put in some number that we want to get the square of, we get the square back out. And again, this isn't especially exciting, but what it goes to show is exactly the structure of how a method is created and how the return works. So let's do a slightly more interesting example. And this time, the other thing is that it doesn't matter where this method goes as long as it is in line with this set right here. So you can't do this. Well, I can't highlight either. You can't do this. No, 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 no. You cannot declare a method inside here because public static void main is actually a method itself. And it's the method that tells the program to go. It's an action. And just like getting the square is an action. And so this has to be in line, and you'll learn a little more about that later. So we can put another one in line here. And as long methods are only enacted if they get called. And so if I don't do anything with get square, nothing will happen because I'm not calling upon it. We have the ability to do it, but until I call upon it, when I run the code, it won't do anything with it. So I'm going to make something to get the tip. And now I have to take into account the fact that the value of a tip and with money isn't going to be an integer. It's going to be a decimal, which we call a double. So static double get tip. And our input is also going to be a double. And I'll call it bill because the tip is going to be dependent on the value of our bill. So then I'm going to say like double tip. Oh, another quick thing. Sometimes when people start off learning, they think that this answer thing is special. Again, this could be called cats, as long as you use it both times, because this is really just like a transitivity that allows it to return the number times a number. So as long as these are consistent, it does not matter what they are. So don't think answer is a magic word, because it's not. Return is a magic word, though. So I'm going to call double tip equal to the bill times 0.15. So that's 15% of the bill. And then I want to return that tip. And that's all. So now what I want to do, I might say like double cost equals 50. Double tip equals get tip of the cost. So given this cost, get my tip for me. And then I can print out the tip. And we get 7.5, which is the tip you would get if you were tipping 15% on a $50 bill. And if I want to bump this up to maybe, 678, the tip's going to be a lot larger. It's going to be 101.7, which is a large tip. And so this is a lot more useful because, maybe we don't have to worry about exactly how to calculate a tip. Let's say you were calculating a whole lot of tips. It would be really, really annoying to type bill times 0.15 every single time you needed to calculate a tip. Now here, you can basically outsource your labor to this method, and now you just get to say, all right, I've got my cost, get my tip for me, and it'll do it for you. So hopefully this video has shown you at least the basics of methods and their uses and kind of how to implement them. And in the next video, we're going to be looking at a lot more uses of methods and what it means when you have multiple arguments to your method. So maybe instead of just the bill, you also need to know how many people were with your party or how good your service was. And you could take all of those numbers or all of those things and mathematically put them together to calculate your tip. And so you can give your tip a dependence on things like how many people you had with you, how good the service was, how good the food was. And based on that, it could determine, how much should I even be tipping? And so it allows you to just pass a bunch of information to this function, and the function gives you what you need back. And if you want to worry about how exactly that's happening, then you can just go down here and edit the function instead of trying to edit something in 10 different places that's being used 10 different times. And so that is the implementation of a basic method or two, and hopefully that was enjoyable, and I will see everybody in the next video.